Welcome to Understand the Math. In this video, we're going to learn how to simplify radical expressions. Radical expressions are just ones that have roots in them, a square root, a cube root, or any other root. We'll start by simplifying some radical expressions with numbers, and then we'll move on to simplifying radical expressions with variables and exponents. Let's start by simplifying the roots of some constants. We're going to simplify the square root of 48 and then the cube root of 250. To simplify the square root of 48, we're going to start by breaking down 48 into its factors. You might know that 48 is equal to 6 times 8, but if you don't know that, it might be easier to just realize that 48 is an even number, so we can break it down into the factors 2 times 24. An even number is always divisible by 2. Now we're going to break down 24. It is divisible by 2, and 2 times 12 is 24. And then we'll do the same thing for 12. Its factors are 2 and 6, and then 6 has factors 2 and 3. When we take the square root of a number, we're looking for perfect squares, so we want to isolate factors that are in groups of 2. We have one group here, and then we have another group here. And then we have a 3 that's left over. When we take the square root of all of these factors, we're going to pull out one factor from each group. We'll pull out a 2 from this group, and then we'll multiply that by another 2 from this group. And then what we have left over is a factor all by itself, so that has to go inside the square root. So we write that as square root of 3. And this simplifies then to 4 times the square root of 3. Let's look at another example. And this one has a cube root in it. We're going to do this the same way we did our first example. It's an even number. So let's write down the two factors as 2 and then 125. 125 ends with a 5, so we know that 5 goes into 125. And that's 5 and 25. And then 25 is a perfect square, and it's equal to 5 times 5. Now we're taking the cube root. So instead of looking for 2 of the same factor, we're going to look for 3 of the same factor. And notice that we have 3 5s, so we can bring that out as a 5. And then we have a 2 left over, so that has to go inside the cube root. So we'll write it like this. And then our answer is just 5, the cube root of 2. Let's now look at some examples where we're going to simplify roots of expressions with constants, variables, and exponents in it. Let's start by simplifying the square root of 20 x cubed y to the 5th. Whenever we have a combination of constants and variables, I like to simplify them separately. So let's start by simplifying the square root of 20. We'll do it just like we did the previous examples. We'll break it down into its factors. We'll start with 2 and then 10, and then 10 has factors of 2 and 5. We're taking the square root, so we need groups of 2. And we can write this then as 2 times what's left over, which is our 5, and that goes inside the square root. Now let's simplify our variables, and then we'll combine both answers. Our variables are x cubed y to the 5th. The square root of any expression is just like taking that expression and raising it to the 1/2 power. So I'm going to write this as x cubed y to the 5th raised to the 1/2. To simplify these exponents, we're just going to multiply them. So this becomes x to the 3/2 times y to the 5/2. Now what we're going to do is we're going to think of 3/2 as 1 plus 1/2. That will help us simplify it. And then we're going to think of 5/2 as 2 plus 1/2. We're just pulling out the integers. Now we can rewrite this as x to the first power times x to the 1/2 power, and then y to the second power times y to the 1/2 power. We'll pull out the integer exponents first, and we'll write this as xy squared times the square root of xy. Now we're going to combine our two answers. Our constants were 2 square root of 5, and then this is what we just got for our variables. We can then write our answer as 2xy squared. We're doing the terms first that are not in the square root, and then we're going to do the square root terms, and we have the square root of 5xy. And that's our answer. Let's now simplify the square root of 18x squared y to the 4th z to the 6th. Whenever you take the square root or any even root of a variable raised to an even power, you have to be really careful, and that's why I wanted to include this example. Let's start by first simplifying the square root of 18. We're going to divide that into the factors 2 and 9, and then 9 has the factors of 3 and 3. So we have one pair, and that means we can bring out a 3 because we're taking the square root of that pair. So we have a 3, and then we're going to multiply it by what's left over, and what's left over has to go in our square root. So this becomes 3 square root of 2. Now let's look at our variables. We have the square root of x squared y to the 4th z to the 6th. Let's do the same thing that we did on the previous problem. We're going to write this as an exponent. So we're going to write the square root as a 1/2. So we have x squared y to the 4th z to the 6th raised to the 1/2 power. Now we're going to multiply, and here's where we have to be very careful. I included the formulas here on the right-hand side. The square root of x squared is the absolute value of x. And the reason for that is when x is squared, it becomes positive. So when we take the square root, we have to get back a positive quantity, which means we have to put the absolute value signs on the x. We're going to write this as the absolute value of x to the 2/2. We're just multiplying the exponents. And then the absolute value of y to the 4/2, and then the absolute value of z to the 6/2. Now let's simplify. This becomes absolute value of x, absolute value of y squared, and then absolute value of z cubed. And we use the absolute value sign because each of those powers that were inside of the square root were even. Now, what's done in practice is to simplify this a little bit further, and I want you to focus on this term right here. It is a squared term, and because it's squared, it's always going to be positive. So in practice, what happens is the absolute value sign just gets dropped. So we're going to write this as absolute x, y squared, absolute z cubed. Now let's go back up to the top and let's combine these two answers. We have this answer and we have this answer. This then gives us an answer of 3 absolute x, y squared, absolute z cubed, and then we have the square root of 2. And that's our final answer. Let's now look at an example that has a cube root in it. We'll begin by simplifying the cube root of 54. I think with this one, it's hard to divide it as 2 times a number. And I think it's easier for this one to just remember that 54 is equal to 6 times 9. So I'm going to write this as factors of 6 and 9. And then 6 has factors of 2 and 3. And then 9 has factors of 3 and 3. Because we're taking the cube root, we are looking for groups of 3. And notice that we have 3 3s. So we can pull that out as a single 3. And then we have a 2 left over. So we will write this as 3 times the cube root of 2. Let's now simplify the cube root of x to the 7th, y to the 6th. Let's write this in terms of fractions. So this becomes x to the 7th, y to the 6th, and our cube root is equal to the fraction 1/3. This gives us x to the 7/3 times y to the 6/3. Let's write 7/3 as 2 plus 1/3, and then our 6/3 is just equal to 2. And this gives us x squared times x to the 1/3 times y squared. And let's simplify this as x squared, y squared, times the cube root of x. Now we can combine our two answers. And this is equal to 3x squared, y squared. And then we have what's inside our cube root, and that's equal to 2x. That's our final answer. I want to look at one more example with you. And this is our most challenging example because it has both a numerator and a denominator. We're going to start by simplifying what's inside the square root first. I want to write down a formula that we're going to use. If we have x to the a divided by x to the b, that's just equal to x to the a minus b. And we're going to use that when we simplify this. Our square root becomes the square root of 12, and then we're going to have x to the 8 minus 6 times y to the 5 minus 2 times z to the 8 minus 3. Now let's simplify those numbers, and this is equal to the square root of 12x squared y cubed z to the 5th. Now we can go ahead and proceed just as we did with our other examples. Let's work on the square root of 12 first. It has factors of 2 and 6, and then 6 has factors of 2 and 3. It is a square root, so we are looking for pairs of 2. So we have two 2's, and then we have a 3, which is left over. So we can write the square root of 12 as 2 square root of 3. Now let's go ahead and work on the algebraic part. We need to simplify the square root of x squared, y cubed, z to the 5th. We're going to write our square root as a fraction. So this becomes x squared, y cubed, z to the 5th, raised to the 1/2. Now let's simplify this. We have to be careful with this because notice we're taking a square root and we have one term, this one right here, that has an even exponent. So when we take the square root, we have to pull back in our absolute value, and we're going to write this as the absolute value of x. We'll go ahead and say 2 over 2, but we know that that reduces to 1. And then we have y to the 3/2, and then z to the 5/2. Let's remember that 3/2 is 1 plus 1/2, and then 5/2 is 2 plus 1/2. Now we can go ahead and simplify this. This is just absolute value of x times y to the 1/2 times z squared times z to the 1/2. We can then rewrite this as absolute x, y, z squared, and then in our square root, we have a y and a z. Now all we have to do is combine this answer with this answer. I see that we have run out of space, so I'm just going to make an arrow here, and we can put our answer down here. We have 2 absolute x, y, z squared, and then we have our square root terms, which is 3y, z. And we'll highlight that because that is our final answer. And that's it. I hope that simplifying radical expressions might seem a little bit easier now, and with a little practice, you'll master it in no time. If this video has been helpful to you, please consider subscribing to my channel.
Keep believing in yourself and have a great rest of your day.